Okay, so this is number 5 in chapter 17. We have an electron orbiting the nucleus. And notice here, notice it says an electron, which refers to one electron. So we know the charge of an electron is 1.6 times 10 to the negative 19 coulombs. And it's in the lowest energy state at a speed. Okay, we have the speed. The electron's traveling at 2.19 times 10 to the 6 meter per second in a circular path with a radius of 5.29 times 10 to the negative 11. What is the current associated with this orbiting electron? So what's our fundamental definition of current? So current has the symbol I, and how do we define current? The basic fundamental definition of current is charge, which is Q, charge per time. This is the definition of current. Now, here's a diagram of what's happening. So here's the nucleus, and then we have this electron that's orbiting around the nucleus, and we're given the radius, and we're given the velocity of the electron. So the first thing I'm going to calculate is the distance around one circle. The electron travels once around the nucleus. Let's find out how far that is. What is the distance around the circle? So that's just going to be circumference. So we go circumference equals 2 pi r. We got the radius right here. You plug that in. The circumference comes out as 3.3238 times 10 to the negative 10 meters. So that's the distance around one circle. Could we find the time for one circle now that we know the circumference? Yeah, because we have the velocity. This is the velocity here. So the definition of velocity is basically, well, you know what? I'm going to use the word speed. In fact, yeah, they use the word speed because speed is scalar. Speed is equal to distance over time. So what's the distance, focusing on one circle, what's the distance around one circle? It's this. It's the circumference. So this is going to be our d. And then we have the speed. The speed was given right here. So rearranging this equation for time, time is going to be equal to the distance around one circle divided by the speed. So we go 3.3238 times 10 to the negative 10 meters. The speed is 2.19 times 10 to the 6 meter per second. So the time for one complete orbit of the nucleus is 1.5177 times 10 to the negative 10th. Nope, sorry, 10 to the negative 16 seconds. All right, we now have enough information to find the current. So we go back to our definition for current. So we're focusing on one electron. It says an electron. We have the charge of the electron, 1.6 times 10 to the negative 19 coulombs. And then the time is right here, 1.5177 times 10 to the negative 16. Should be negative 16 seconds. And this comes out as 0.00105 coulombs per second. But what's a coulomb per second? That's an amp. And if you want to be cool, you could just say 1.05 milliamps. But I think the back of the book gives it in amps.